ozone depletion, greenhouse gases, acid rain, and photochemical smog are caused by excess of certain gases in the atmosphere due to human activities. Can you name the gases that cause these problems? Can these gases be identified? How? At the end of this lesson, students should be able to describe tests for the identification of gases.
Gases are often liberated when salts are heated or reacted with acids or alkali. The gases liberated must be identified through confirmatory tests for gases. Why? Because with these tests, we are able to make differences about the types of anions present in a salt. These are the gases liberated during chemical tests carried out on salts. How do we identify these gases? What are the confirmatory tests for these gases? Click on the gas to find out. Heat strongly 1 spatula of solid potassium chloride 5 in a test tube. As potassium chloride 5 decomposes, oxygen gas, which is a colorless and odorless gas, is released. Insert a glowing splinter into the gas. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your answer. Name the gas liberated when potassium chloride 5 is heated. Sorry, try again. What is the confirmatory test for this gas? The confirmatory test is carried out. Sorry, try again. Pour 4 cubic centimeter of diluted sulfuric acid into a test tube containing a spatula of zinc powder. As zinc powder reacts with diluted sulfuric acid, hydrogen gas, which is colorless and odorless gas, is released. Insert a lighted splinter into the gas. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your answer. Name the gas liberated when zinc powder reacts with diluted sulfuric acid. Very good. What is the confirmatory test for this gas? Sorry, try again. What do you observe when the confirmatory test is carried out? Sorry, try again. Heat strongly 2 spatulas of zinc carbonate in a test tube. As zinc carbonate decomposes, carbon dioxide, a colorless and odorless gas, is released. Bubble the gas into a limewater. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your answer. Name the gas liberated when zinc powder reacts with diluted sulfuric acid. Sorry, try again. What is the confirmatory test for this gas? Sorry, try again. What do you observe when the confirmatory test is carried out? Sorry, try again. Heat a mixture of 4 cubic centimeter of potassium hydroxide solution and 1 spatula of ammonium nitrate in a test tube. When heated, potassium hydroxide solution reacts with ammonium nitrate. Ammonia gas, which is a colorless gas with a pungent smell, is liberated. Test the gas with moist litmus papers. Carefully dip a glass rod in concentrated hydrochloric acid and insert the glass rod into the gas. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your answer. Name the gas liberated when potassium hydroxide solution reacts with ammonium nitrate. Sorry, try again. What are the confirmatory gas tests for ammonia and what are the expected observations? Heat a mixture of 2 cubic centimeter of concentrated hydrochloric acid with a spatula of manganese 4 oxide in a test tube. When heated, concentrated hydrochloric acid reacts with manganese 4 oxide, chlorine gas, which is a greenish-yellow gas with a pungent smell, is liberated. Test the gas with moist litmus papers. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your answer. Yes. Sorry, try again. What do you observe when the Sorry, try again. Heat a mixture of 2 cubic centimeter of concentrated sulfuric acid with a spatula of sodium chloride pellets in a test tube. When heated, concentrated sulfuric acid reacts with a spatula of sodium chloride pellets. Hydrogen chloride gas, which is a colorless gas with a pungent and choking odor, is liberated. Test the gas with moist litmus papers. Carefully dip a glass rod in concentrated ammonia solution and insert the glass rod into the gas. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your gas tests for hydrogen chloride and the expected observations. Heat a mixture of 5 cubic centimeter of dilute hydrochloric acid with 2 spatulas of sodium sulfite in a test tube. When heated, hydrochloric acid reacts with sodium sulfite and sulfur dioxide gas, which is a colorless gas with a pungent odor, is liberated. Test the gas with moist litmus papers. Bubble the gas liberated into 2 cubic centimeter of acidified potassium dichromate 6 solution. Bubble the gas liberated into 2 cubic centimeter of acidified potassium manganate 7 solution. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your answer. Name the gas liberated when sulfuric acid reacts with sodium sulfate. Expected observation. Strongly heat a spatula of zinc nitrate powder in a test tube. As zinc nitrate decomposes, nitrogen dioxide, a brown and pungent gas, is released. Test the gas with moist litmus papers. What do you observe? Now, answer these questions. Key in your answer, then click the check button to check your answer. Name the gas liberated. Out. Sorry, try again.
Divide the class in. In this lesson, you have learned that different gases have different properties. Each gas can be identified and confirmed by 1 or 2 specific tests. This table shows a summary of the different properties and specific tests for each gas. Auroras are glowing streaks in the sky seen at night in the far north and south. Aurora features come in many shapes and colors. Most of the aurora features are greenish-yellow, but sometimes the tall rays will turn red at their tops and along their lower edges. Let us do some research on auroras. What makes them happen? What causes auroras to have different colors? What effects do auroras have on the Earth? Write an article based on your findings.